Good morning, students. I'm very happy to meet with you in another class. I hope you have started learning now. In the previous class, we discussed about definition of chemistry and the scope and importance of chemistry. I hope you might have learned what are the importance of chemistry in our day-to-day life, how chemicals are useful in our life, isn't it? And can you tell me the definition of chemistry now? Chemistry is the branch of science, right, which deals with structure, composition, and properties of matter, right? So, chemistry deals with matter, right? So, today's class we are going to see matter and its classification, right? So, now matter has two classification: physical classification and chemical classification, right? So physically matter are three types, no? You would have learnt in your ninth class, I hope, right? Solid, liquid and gas, right? And solid are the matter in which atoms are closely packed. It possesses rigidity, right? Liquid atoms are loosely packed in comparison to solid, and they possess fluidity. What about gases? Atoms are very loosely packed and they are highly compressible and possess fluidity, right? So these things and all you have learned in your ninth class. And tell me, what are the other two forms of matter? Yes, correct. Plasma and Bose-Einstein condensate. So these two are formed at extreme temperatures. Plasma is known as superheated gaseous ions. It is formed at very high temperatures, right? What about Bose-Einstein condensate? It is known as supercooled atoms. So it is formed at the very low temperatures. Practically these two are difficult to achieve. So commonly we see solid, liquid and gas, right? Now we'll see what about chemical classification. Chemically, matter are two types: mixture and pure substance. So mixture in the sense two or more substance mixed in any ratio. So mixture are two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture, it is the mixture, it has uniform composition throughout. Example, when we dissolve salt in water, it mixes up thoroughly, isn't it? And what about heterogeneous mixture? Heterogeneous mixture has distinct boundaries. You can see two phases or two substances differently, right? Oil in water, you can see these two are immiscible. Salt and sand, you can distinguish them. So these are example of heterogeneous mixture, right? Now pure substance. What is pure substance? So chemically pure substance means it is made up of only one kind of atom or molecules, right? So under pure substance we have element and compound. What do you mean by element? Element is the pure form of substance made up of only one kind of atoms or molecules, right? Example, gold, silver, aluminium, copper, etc., etc. What about compound? Compound is also pure substance made up of two or more elements chemically combined in fixed proportion by mass. Example, water, carbon dioxide, ammonia, etc., etc. Right. What do you mean by atom? So atom is the simplest substance of an element which cannot be broken down further, isn't it? Right. Molecule is again a simplest form of an element. It can be diatomic, homoatomic, or heteroatomic molecules. Right. Next, properties of matter and their measurement. Properties of matter and their measurement. Physical matter have two properties: physical properties and chemical properties. What do you mean by physical properties? Physical properties are the properties of matter measured without the change of composition of matter. Example: mass, volume, density, melting point, boiling point. In these cases, matter do not undergo any change. Right? We measure these properties without disturbing the composition of matter. Right? Now, what about chemical properties? Chemical properties are the properties of matter in which a matter undergoes a chemical change. For example, oxidation, reduction, reaction with acid or base. So here we learn that matter undergoes a complete chemical change. Right. Now we will be learning in detail in our future chapters. Now, SI unit system. All the physical properties are quantitative in nature. So in order to express a physical quantity, you need two factors. One is number, the other one is unit. Right. So in our country and throughout the world, we come across different type of unit systems, but internationally we accept only one type of unit system, that is SI unit system. Right. So SI unit system recommend 7 basic physical quantities. I hope you are aware of it. Right. For example, to express weight of watermelon, for example, weight of watermelon is 4 kg. So here 4 is number and kg is the unit system. To express a physical quantity, you need two factors, number and unit system. Right. So now we are going to see what are the 7 basic physical quantities and their units. So here in this slide you can see SI unit system recommends 7 basic physical quantities. Right. Length, meter, mass, kilogram, time, second, electric current, ampere, temperature, Kelvin, amount of substance, mole, luminous intensity, candela. Right. So these are 7 basic physical quantities and we must know with the SI units. Right. Next, derived units. So here there are other physical properties, such as velocity, area, density, volume, acceleration, etc., etc. So what will be the SI unit of these physical quantities? So SI unit of these physical quantities are derived from the basic units of 7 physical quantities. Right. So for example, area. So area is meter squared, density kilogram per meter cube, volume is meter cube, velocity meter per second. So the units of these physical quantities are derived from the units of 7 basic physical quantities. Right. Right. Next we have subsidiary units. So subsidiary units are nothing but we add prefix to the unit of 7 basic physical quantities. So this unit system is required, when based on the size of the matter or quantity of matter. Okay. Now for example, if I ask you what is the distance between our school to Gandhipuram, you may say it is 5 kilometer, distance. So meter is the SI unit of length, but here we are using kilo. So kilo is the prefix. We use it to express the length of the matter, kilometer. Now, what is the distance between two walls of your classroom? So you may say 5 meter, 10 meter, like that. Okay. So now what is the length of your small scale? You will say centimeter. So here centi is the prefix which comes under subsidiary unit system, right? Then again smaller, millimeter, then micrometer, nanometer. As the particle goes very small, we change the prefix. So this prefix system is also very essential to express the physical quantity of matter, right? Next, another important thing we use in the science or in chemistry, scientific notation, n into 10 power n. So here capital N represents number or digit term, and small n represents an exponent having positive or negative values. So what is this scientific notation and why it is necessary and where it should be used? So scientific notation, it is a simple mathematical form to express a very large numbers or very very small numbers involved in the science. For example, we all know about Avogadro number. Can you write down Avogadro number? 6 0 2 2 0 0 0 0 0 0 0 0 0, and it goes on. Okay. And how will you use this in a calculation? Such a huge number. It's quite difficult, isn't it? So therefore we need a simple form to express this such a big number in a easy manner, that is known as scientific notation. So here we use decimal places, right? So now when we move decimal places towards left side, the positive value increases, the small n value increases, right? At the same time, when you move the decimal places right side, the negative value decreases. So now the Avogadro's number can be expressed in a simple manner, 6.022 into 10 power 24, right? So how it is easy to express such a huge number in a simple manner. Similarly, another example is given here, mass of a hydrogen atom, 0.00000000000000166 gram. Oh, what a difficult to even to say, how it will be difficult to write in a paper, isn't it? So to express such a very very small number in a easy form, we use scientific notation. Here we move decimal place in the right side. As the decimal place moves to right side, negative value increases and positive value decreases. So now this can be written in an easy manner, 1.66 into 10 power minus 24 gram. Okay, isn't it easy? It's a wonderful technique, while solving numericals. So the scientific notation is a great use, so we must learn how to write a given number in scientific notation. Okay, right. So in this class we have learnt about matter and its classification. Then we have learnt properties of matter, physical properties and chemical properties. Then we also learnt physical properties are quantitative in nature. So SI unit system recommends 7 basic physical quantities with their SI units. Then we learn subsidiary units, derived units. Okay, all these things, and scientific notation, all these things are very important fundamental basic things while solving numericals in chemistry. So all these techniques we will be applying in future chapters, in forthcoming chapters, right? So dear students, I request every day you must go through these topics, whatever we teach you, go through this and solve the in-text questions, solve questions first, then you go through exercise questions. We'll meet you with another class. Thank you very much.